You're moving right now, 230 kilometers per second. That's fast enough to circle the entire Earth in 3 minutes. And you've been doing this since the moment you were born. Your parents did it, your grandparents, every ancestor stretching back through time, every human who ever drew breath, every star you've ever seen twinkling in the darkness. All of it. 200 billion stars, swirling clouds of gas, entire solar systems, locked in a vast, patient dance around the same invisible point. And at that point sits something so massive, so incomprehensibly powerful, that it bends space itself into submission. A supermassive black hole, 4 million times the mass of our sun. And for almost all of human history, we had no idea it was even there. Tonight, we're going to trace the story of the most important object you've never seen, the invisible giant at the center of everything we know, the thing that's been pulling you through space your entire life without you feeling a thing. This is the story of Sagittarius A star, the dark heart beating at the center of the Milky Way. For thousands of years, people looked up and saw a river of light stretched across the night sky, the Milky Way, beautiful, mysterious. Just light. By the early 1900s, we finally understood what we were looking at. A galaxy, spiral, vast, with Earth sitting off to one side, about 2/3 of the way out from wherever the center might be. We assumed there was a center, some dense cluster where starlight pooled together more brightly than anywhere else, but we thought it was just more stars, packed tighter, nothing special, nothing worth worrying about. The problem was, we couldn't see it. Between us and the galactic center, enormous clouds of gas and dust block all visible light completely. When you point a normal telescope towards Sagittarius, you see nothing, just darkness. For centuries, the center of our own galaxy remained hidden, a blank spot in our cosmic map. Then, in the 1970s, something changed. Radio telescopes began scanning the galactic center. Radio waves can pass through dust like sunlight through fog, and they found something strange, a powerful, compact radio source, bright, concentrated, perfectly still. Too bright to be ordinary starlight, too small to be a cluster, too focused to be a gas cloud. They named it Sagittarius A star, after the constellation where it appeared. And immediately scientists knew, something massive was sitting there, something invisible, pulling everything toward it like water circling a drain. But here's the thing about black holes. You can't see them, you can only see what they do to everything around them. In the 1990s, 2 teams of astronomers began one of the most patient, most ambitious experiments in the history of science. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, both aimed at the same patch of sky, the galactic center. Using infrared cameras that could see wavelengths invisible to human eyes, they started tracking individual stars near Sagittarius A star. Not hundreds of stars, just a few dozen, year after year, image after image, watching them move like a detective studying security footage frame by frame. And the stars move fast. Not the slow, lazy drift you'd expect from objects so far away. These stars were whipping around something invisible at terrifying speeds, like planets orbiting a sun but far more extreme. Tight orbits, elliptical, violent. Something was there, something with gravity so strong it could fling entire stars around like toys. One star became the key, a blue-white star, unremarkable except for where it was and how it moved. The teams called it S2. And S2's orbit would prove everything. S2 orbits Sagittarius A star every 16 years. That's extraordinarily fast for something orbiting the center of a galaxy. Our sun takes 230 million years to complete one orbit around the galactic center. S2 does it in 16. At its closest approach, the point astronomers call periapsis, S2 gets within 17 light hours of the black hole. For reference, Neptune sits about 4 light hours from our sun. S2 gets 4 times closer to a supermassive black hole than Neptune does to our relatively tiny star. And at that distance, it accelerates to about 2 to 3% the speed of light, 7,000 kilometers per second. fast enough to cross the distance from Earth to the Moon in under a minute. Scientists followed S2 for decades, tracking its motion year after year. They watched it sweep past the black hole in 2002 and again in 2018. One full 16-year orbit from close pass to close pass. And they're watching it right now, already partway through its next orbit, frame by frame, year by year. They could see it accelerate as it approached periapsis. They could see it decelerate as it swung away. The path was perfect, mathematical, exactly what you'd expect from an object orbiting a massive point source. And then they did the math. To make a star move that fast in an orbit that tight, there has to be something incredibly massive at the center, concentrated in a space smaller than Mercury's orbit around the Sun. The numbers came back precise, roughly 4 million solar masses, packed into a region of space so small it defied explanation. No star cluster could be that dense without collapsing. No gas cloud could stay together under that kind of gravity. No normal object in the universe could hide that much mass in that little space. Only one thing fit the evidence: a supermassive black hole. By 2002, the case was closed. Sagittarius A star wasn't just a radio source, it was a black hole. Our black hole. The thing we'd been orbiting our entire lives without knowing. For decades after that, we knew it was there. We could measure its mass, track stars orbiting it, map its gravity like archaeologists mapping a buried city. But we'd never actually seen it. We'd never looked it in the eye. In 2019, the Event Horizon Telescope, a planet-sized network of radio dishes working in perfect synchronization, revealed the first ever image of a black hole, M87 star, at the center of a galaxy 55 million light-years away. A glowing ring, a shadow at the center, proof that black holes weren't just mathematical predictions, they were real. They were out there, and we could photograph them. And then, in May 2022, the Event Horizon Telescope released a second image, this time closer to home: Sagittarius A star, the thing at the center of our galaxy, the invisible giant we've been circling since before life even began on Earth. It took longer than M87 star because Sagittarius A star is more difficult to photograph. M87 star is massive and stable. It changes slowly over days or weeks. Sagittarius A star is smaller and it flickers. Gas swirls around it on timescales of minutes to hours. Brightness shifts constantly. Like trying to photograph a child who won't sit still, except the child is also 26,000 light-years away and surrounded by superheated plasma moving at a significant fraction of the speed of light. But the team synchronized data from telescopes scattered across the entire planet. Chile, Hawaii, Arizona, Mexico, Spain, Antarctica. Multiple observatories working as one machine, combining signals, compensating for Earth's rotation, adjusting for atmospheric distortion, building an image pixel by painstaking pixel. And then they had it. A bright ring of hot gas, its light bent into a perfect circle by gravity so extreme it warps the fabric of space itself, circling the event horizon. And in the center, a shadow, a dark silhouette where light is captured and never escapes. 52 micro arcseconds across. That's like seeing a donut sitting on the surface of the moon from Earth, or reading a newspaper in New York from Los Angeles. For the first time in history, we saw the face of the thing we'd been orbiting our entire lives. And here's the strange part. Sagittarius A star is not a quasar. It's not blazing with energy. It's not devouring stars every night and shooting jets of radiation across the cosmos. Most of the time, it's quiet, starved, a giant with its mouth closed. Which means we're looking at something even stranger than a monster. We're looking at a supermassive black hole at rest, sleeping, waiting. And seeing it made us ask, what are we actually looking at? What does 4 million solar masses really mean? 4 million solar masses. That's 4 million stars like our sun compressed into a singularity, into a point of infinite density where the laws of physics as we understand them simply stop working. Let's put that in context. If you could somehow compress our sun, this 1.4 million kilometer wide ball of fusion that gives life to everything on Earth, into a black hole, It would have an event horizon about 6 kilometers across, a tiny sphere. Now imagine doing that 4 million times and crushing all of it into a single point. That's Sagittarius A star. The event horizon of Sagittarius A star is about 24 million kilometers across, roughly 17 suns laid side by side. Light, moving at 300,000 kilometers per second, crosses that diameter in about 80 seconds, a minute and 20. That's the boundary, the point of no return. And it's worth saying out loud, the event horizon isn't a surface, it's not a shell you could touch. It's a line in space where escape stops being a direction you can travel. Inside it, our everyday understanding of reality breaks down. Not because the black hole is made of darkness or evil, but because gravity is so extreme that even light, the fastest thing in the universe, can't climb back out. And deeper still, our equations predict a singularity, a place where the math stops making sense and physics runs out of language to describe what's happening. Now, if you put Sagittarius A star where the sun is, the event horizon would still fit inside Mercury's orbit, but the mass would be 4 million suns. Earth, at our current distance, would not be able to orbit the way it does now. To stay in a stable orbit at 1 astronomical unit, Earth's current distance from the sun, you need to travel at about 1/5 the speed of light, and your year would last just over 4 hours. So the horizon is small compared to the solar system, but the gravity is not. Now consider the mass itself. The sun weighs about 333,000 Earths. It's so massive that its gravity holds 8 planets in orbit across billions of kilometers. Sagittarius A star is 4 million times more massive than that. That's 1.3 trillion Earths, 1,300 billion Earths. If you somehow lined up planet-sized objects, each one as massive as Earth, you'd need 1.3 trillion of them to equal Sagittarius A star's mass. Lined up edge to edge, that chain would stretch to the nearest star and back about 200 times. Let's compare it to other black holes. Sagittarius A star, 4 million solar masses. M87 star, the black hole photographed in 2019, 6.5 billion solar masses. TON 618, one of the largest black holes ever discovered, 66 billion solar masses. TON 618 is 16,000 times more massive than Sagittarius A star. By comparison, our black hole is tiny, but tiny is a relative term. 4 million suns, 1.3 trillion Earths. Incomprehensible mass, crushed into infinite density, and it's sitting right there at the center of our galaxy. Sagittarius A star is 26,000 light-years away, the closest supermassive black hole to Earth. And here's something that should make you uncomfortable. When we look at Sagittarius A star, we're not seeing it as it is now. We're seeing it as it was 26,000 years ago, when humans were living through the last ice age. Small bands huddled around fires, stone tools, cave paintings. The first cities were still 10,000 years in the future. Writing didn't exist. Agriculture hadn't begun. And photons of light were leaving Sagittarius A star, beginning a journey through dust, through spiral arms, through the quiet lanes between stars, until they finally reached our telescopes in 2022. Sagittarius A star is ancient. It likely formed in the early universe, billions of years ago, when galaxies were young and still colliding and merging, when the first stars were just beginning to illuminate the cosmos. Sagittarius A star was already there when our solar system formed 4.6 billion years ago, already massive, already ancient. It was there when life first appeared on Earth, when the dinosaurs ruled and died, when the first humans looked up at the night sky and wondered what those points of light were. It will still be there long after the sun dies, long after Earth is gone, long after every star we can see has burned out or drifted away into the expanding void. And it's been doing the same thing the entire time, pulling, holding, anchoring. Right now, in this present moment, Sagittarius A star is doing something, pulling gas inward, maybe flaring as a cloud drifts too close, maybe quiet. Stars are orbiting it. S2 is somewhere in its 16-year path. Other stars are accelerating toward periapsis or drifting away. The event's horizon is there. The ring of light is glowing. Something is happening, but we can't see it. The light that would show us Sagittarius A star as it is right now, in this exact moment, won't reach Earth for 26,000 years. Think about that. 26,000 years from now. Modern humans appeared roughly 300,000 years ago. 26,000 years is nearly 1/10 of the entire span of human existence. In 26,000 years, human civilization might be unrecognizable. We might have spread across the galaxy or destroyed ourselves, or evolved into something we wouldn't even recognize as human. Earth's climate will have shifted. Continents will have drifted. Species will have gone extinct. New species will have appeared. The stars in the night sky will have moved to different positions. And only then, 26,000 years from now, will the light from today's Sagittarius A star finally arrive. Only then will observers, if there are any, see what Sagittarius A star looked like in the year 2026. We're always watching the past, never the present. The black hole we photographed in 2022, that was Sagittarius A star as it existed 26,000 years ago. S2's orbit that we've been tracking since the 1990s, we're watching events that happened 26,000 years before we saw them. Everything we know about Sagittarius A star, every measurement, every observation, every image, is ancient history, and there's no way around it. Light has a speed limit. Information has a speed limit. We are separated from Sagittarius A star not just by distance, but by time itself. A 26,000-year gulf we can never cross. What is Sagittarius A star like right now? We can't know. Not for 26,000 years. All we have is the past. Always the past. But the past is enough to tell us what Sagittarius A star does. It doesn't hold the entire Milky Way together by itself. The galaxy is bound by all of its mass, stars, gas, and the mysterious dark matter we still don't fully understand, added together. But Sagittarius A star rules the inner heart of it. Near the core, its gravity dominates. It sets the rhythm of the closest stars. It anchors the very center we measure everything from. And in that sense, quietly, relentlessly, it is the dark landmark at the center of home. We orbit at 230 kilometers per second, fast enough to circle Earth in about 3 minutes. But the galactic center is so far away that one complete orbit takes about 230 million years. Think about that. The last time our solar system was in this position in its orbit, dinosaurs hadn't appeared yet. The next time we come back around to this spot, 230 million years from now, Earth might be unrecognizable or gone. Stars closer to Sagittarius A star orbit faster. S2 completes an orbit in 16 years. S62, another track star, has one of the shortest known orbits, just 9.9 years, screaming around the black hole at nearly 10% the speed of light at periapsis. Farther out, stars take thousands of years per orbit, and at the edges of the galaxy, 70 or 80,000 light years from the center, stars crawl through their orbits over hundreds of millions of years. Some stars have been circling Sagittarius A star for billions of years. They'll keep circling for billions more. Generations of stars, born and dying, all held in orbit by the same invisible anchor. Sagittarius A star doesn't care. It doesn't hurry. It doesn't rest. It's patient. It's invisible, silent, but absolute. Every star near the core bends to it. Every orbit, every trajectory, every motion shaped by its gravity. You can't negotiate with it. You can't escape it. We're bound to it, the quiet tyrant at the center of everything. Right now, somewhere near the constellation Sagittarius, there's a black hole. You can't see it with your eyes. You can't point to it in the sky and say there. But it's there, and you've been circling it your entire life. So have your parents. So has every generation before you. So has every star you've ever seen. All of it held by something we couldn't even photograph until 2022. Something we still can't see as it is, only as it was 26,000 years ago. The dark heart of the Milky Way. Not the most massive black hole in the universe, not the farthest, not the brightest, but ours, the center of home. Patient, quiet, inescapable. You're orbiting it right now. You were orbiting it when you were born. You'll be orbiting it when you're gone. Always turning, never arriving. Always seeing it late, never seeing it now. The invisible thing at the center of everything. The thing you can't escape. The thing you've always been bound to. Sagittarius A star, the dark heart of the Milky Way.